Now, when we're substituting in values of x to our function, it's quite straightforward. We just sub in whatever value of x we're interested in. For example, we can write, if this is our function, then when x equals 1, y equals, and now here I've just written out the function again, but instead of writing x, I've put 1 instead. Obviously, I could probably figure out what that is in my head, but I've just shown my working, and of course I get 7. Now, if we define y as a function of x by actually writing, let's let y equal f of x, and that's how we say this. We don't say f bracket x, we say f of x. Let's write that down on our notes. F of x, just so you know how it's said. Then we would just write the exact same thing as this, but instead of putting the y there, we would say, let's not use y this time, we'll use f of x. Now, why are we going to do this? Well, it's got two main advantages. For one thing, it makes it nice and easy for us to use shorthand when we're substituting things in. Now, you might look at this and go, that's not much shorter, but in maths, if we're doing a lot of things, just saving any time can be really handy. So here I've gone ahead and I've subbed in x equals 1. Now, because f of x, it's like it's saying we've got a recipe here for what to do with the x, double it and add 5. And over here, the part in brackets is saying, I've got a recipe, the ingredient that we're cooking with is x. So you say, okay, what do we do with the x? Okay, well, you times it by 2, multiply it by 2, and then add 5. Okay, that seems fair enough. So what we have here when we write f of 1, now we're cooking with our main ingredient being 1. And what's the recipe? Well, the recipe is the same as what was above. Take whatever you're cooking with, in this case 1, double it, and add 5. So here, I've literally just replaced the x with a 1. So when I've subbed it in, I've replaced the x with a 1. And of course, I get the same answer of 7. I haven't done anything amazing here. All I've done is used different setting out. Now, the replacement that I've made, instead of having to write this, when x equals 1, y equals, instead I just wrote this. Tiny bit less pen used. It's a tiny bit shorter. Okay, I hear what you're saying. It's not a massive time saver, but it's quite handy because it saves us having to write out that bit every time. And if we're making a lot of substitutions, we might want to put f of 1 equals this, f of 2 equals that. We can also sub in unusual looking things. Here I've subbed in, what about when x is a plus 5? And instead of writing when x equals a plus 5, y equals, I just said f of a plus 5 is, and I just literally followed the f of x formula, followed the recipe, but anywhere they had an x, I'm going to put an a plus 5 in brackets. So we do 2 lots of, not x, but 2 lots of a plus 5 plus 5. Now I can simplify that out and say, well, that's 2a plus 10 plus 5. And the 10 plus 5 I've added in my head and said, well, that's 2a plus 15. So let's look at another example now. Here I've got a different function. If f of x equals x squared minus 3x, find f of 4 and f of x minus 1. All right, so all I have to do here to find f of 4, this is a recipe. It tells me we're cooking with x, and this is what we do with the x. We square it, and then we subtract 3 lots of it. So here, it's like I'm cooking with 4. What do I do with my 4? I need to square it, and then subtract 3 lots of it. So literally the first line, you should just sub in directly. Wherever they had an x, it tells you what goes in here. That's what they've used. You put in your 4 and square it. It's helpful to put it in brackets, especially if it's something complicated like this. Now we can tidy it up and say, well, I know 4 squared is 16 and minus 12. You might do that line in your head and jump straight to writing that the f of 4 in this case is 4. All right, f of x minus 1, we'll need to go carefully here. This means that we've got not x squared, but x minus 1 squared. And we need it to stay in the brackets like that. And then we need to subtract 3 lots of not x, but what we have in our brackets, which is x minus 1. So I've just made a direct swap. Instead of x, everywhere they have an x, we've used an x minus 1. Now, I could leave this like this, but it seems to me that it makes sense to tidy it up. I can see 2 ways that I could tidy it up. I could either factorize it, or I could just expand it and then gather up like terms. Let's expand it. This first part becomes x squared minus 2x plus 1. And the second part, we have minus 3x careful not to make a classic sign error, minus 3 multiplied by minus 1 is plus 3. And now we can gather up our like terms. We have x squared minus 5x plus 4. Now that can actually be factorised if we want to. I can see that we could actually turn this into x minus 1 and x minus 4, but it hasn't really strictly asked us to do that, so you might as well stop here. Both of these are kind of like 6 of one, half a dozen of the other. So I mentioned that there's two main advantages to function notation, which is using that f of x instead of y. One, which we've just seen, is that it makes it easier to sub things in without having to write out when x equals this, y equals that. But the other main advantage is that if you're graphing more than one function, then you can give them different names like this and just use different letters, and straight away you've got 26 different letters of the alphabet that could be out the front. Now, at first this makes not much sense because you're like, hang on, this is f of x. Doesn't f stand for a function of x? Well, if that's the case, what's this? A gunction and a hunction? Are we going to have a junction next? I mean, that's actually a word. Well, sort of, yes. And if you want to call these junctions and hunctions just to be silly, go for it, because that'll help it stick into your memory. But really what we're doing here is we're just saying it makes it easier for us to label our functions if we can give them nice clear names like this. Now this allows me to have a Cartesian plane that has an x-axis and a y-axis. And yet when I graph each of these functions, rather than call it y equals 2x on the blue one, I can actually just call it let y equal f of x. Because here, what I've graphed here is actually the line y equals 2x. Right? So I've let y equal f of x. It's almost like I've named this blue line here f of x. Now, okay, 2x isn't much of a mouthful. F of x looks like it's about the same, but some of the functions that we're going to deal with have long, complicated formulas, and if you've got to write that whole formula on the line, it can get really messy. So really, this is just a tidy way of saying this is y equals f of x, y equals g of x, y equals h of x, and if you want to know the actual formula for how you find each of those, then it can be listed separately on the side. And lastly, just a couple of common pitfalls that we want to avoid. Be careful when you're subbing in negative numbers. We've talked about this before, but I can't say this often enough because it's just a common mistake. If you're doing something like, okay, here, if fx equals x squared minus 1, find f of negative 3. So f of negative 3 equals, now using brackets is going to help you here. We want all of negative 3, the whole thing, the negative part and the 3 part, to be squared. And then we want to subtract 1. Now, you can do this in your head. Your head will be probably better at it than your calculator, because we've already seen that if you put this into your calculator just like that, your calculator will square the 3, because that it does indices first, and get 9. Then it will multiply by negative 1, and it will tell you that it's negative 9. Okay, now that's not what we want here, because we want negative 3 all squared, including the negative part. So what we should get is we can either put it in our calculator like that, but let's face it, we should know that 3 3s are 9, and we should also know that a negative times a negative is a positive. We can see that this part is 9, and we've got 9 minus 1, so we can be really careful with it and say we've got 8. Down here, we need to be careful to use brackets. Okay, here brackets helped us, but we need to use brackets especially to avoid the classic sign error when we're subbing in something that's got two parts, especially if we're subtracting something that's got two parts. So here, if f of x equals, say, 5 minus x squared, then if we're finding f of x minus 2, that means we're going to need the 5 minus bracket x minus 2 all squared. Now, at this point, an error can creep in. When you expand this out, one common error is to not include the middle term. Remember that this is going to expand to x squared minus 4x plus 4. My tip would be, do that extra line of working where you expand this out first, remembering the middle term, and then multiply everything by this negative 1 that's out the front, which will change the sign. Now at this point you can do some things in your head. Just, I think this line is important so that you don't make the classic sign error, because this negative here is going to affect everything in there. So if we look at the x squareds first, we've got negative x squared. This negative 4x is multiplied by negative 1, so it's actually a plus 4x. And then we've got 5 minus 4, which is 1. So that's the correct answer there. And that shortcut that we took with not having to write out when x equals this, y equals that, can help us make even more shortcuts when we want to do fancy things with our function. For example, here we've got one that's not f of x, it's h of x. We've learnt that's okay, it's just sort of some sort of recipe of something we're going to do with the x. We're going to double it and add 5, same as we did before. In this example, it's a little bit trickier. We want to find 4 h of 3. Now, two-step process here. This is handy because instead of having to say let x equal 3 and then when you get the answer multiply the whole thing by 4, that would be quite wordy to write out. And yet you can literally write out what you want someone to do nice and quickly like that. Now for a question like this, I would recommend at first, as you're learning, just do things in 2 steps. First, let's work out what h of 3 is. Well, here it's like a recipe of what to do with the x. We need to do the same thing with the 3. So we need to do 2 3's plus 5. And that gives us 6 plus 5, which is 11. Therefore, 4 lots of h3 is just going to be 4 lots of 11. So we've got 44. Nice and simple.